Hi, welcome to another trig lesson with Miss Johansson. I'm Miss Johansson, and in today's lesson we're going to be learning about solving right triangles. The definition of solving a triangle is to find all the missing measurements of the angles and sides to have all the measurements of the triangle. So we're going to be looking today at two different problems you're going to see involving solving right triangles. One of them, you're going to be given certain information, the other one, different information. The first one is when you're given two sides of a triangle and you have to solve it given that information. The other one is if you're given an angle and a side and you have to solve that triangle. So the first one that I'm going to show you is when you're given two sides, and I'll show you an example of how to solve that. So here we have a right triangle, triangle ABC, and the given information is side B and side A. Side B is 7 and side A is 11 degrees, 27 minutes. So now that we have our given information, you need to organize your thoughts and find out what do I need to find. And you can write that down. We need to find angle A. And angles are always capital letters, whereas sides are lowercase letters. We need to find angle B and side C. It should be a lowercase. So, I think the easiest thing to start out with is finding side C, because you can easily use Pythagorean theorem to do that. So that would be 7 squared plus 11 degrees, 27 minutes squared equals C squared. So if you use your calculator and making sure that it's in degree mode, 7 squared plus 11 degrees, 27 minutes squared. And if you don't remember how to access the degrees, minutes, seconds feature on your calculator, you can look at the previous videos or ask me about it in class. So this equals 180.1 equals C squared, and of course that's squared. So we need to find the square root of 180.1. And that is equal to 13.4 equals C. And we can write that in here and in here. So now that we have all three of the sides, we can fill in trig ratios to find the angles, the missing angles. So, for instance, we're finding angle A. So we know that a tangent ratio would be opposite over adjacent. So we can fill in the given information with the missing angle. So that would be opposite, which is 11 degrees, 27 minutes over 7. So all that's missing from the equation is the angle. And obviously, when you are missing the angle, you use inverse, because when I say inverse, you say angle. Inverse, angle. So, angle A is equal to tangent inverse, which is written as a -1 exponent, times 11 degrees, 27 minutes over 7. And you can enter the whole thing in your calculator by clicking second tangent key, and then in the parentheses 11 degrees, 27 minutes over 7. And that would be angle A equals 58.6 degrees. We can fill that in here. So, to find angle B, the last missing angle, there's a couple ways you can do it. One of them being the same way as you found angle A, which was finding a trig ratio. For instance, you could do the tangent of angle B is 7 over 11 degrees 27 minutes, and then do the inverse that way. Or, since we all know that all the angles in a triangle add up to 180 degrees, we can do 180 and subtract the already given angles and found out angles to find the last missing angle. 180 minus 90 minus 58.6 equals 31.4 would be the missing angle, degrees. So, now that we have all the measurements in the triangle, we have solved the triangle ABC. And the way we did that is by finding the missing side and then using Pythagorean theorem, and then with all the given sides, we inputted that into the trig ratios with the missing angle and then used inverse to solve for the angle. Now I'm going to show you the second type of problem where you solve right triangles. In this problem, you're given a side and you're given an angle. And I'm going to show you a real-life application of what this might look like if you saw it in the real world. So I'll label these points. So, say this is a building that is 12 feet high. And at point B, there is a bird. And the bird flies at an angle of 32 degrees to the top of the building. The things that we need to find to solve the triangle, to solve for the distance from the starting point of the bird to the top of the building, is we're trying to find that distance, and we're also trying to find the distance from the starting point of the bird to the bottom of the building. And those are the things that we're trying to find. So we can say that we're trying to find side C and angle A, and also side A. I think the easiest thing to start out with is finding side A, angle A. Finding angle A is easy because we already have these two angles. And so you can subtract both those angles from 180 degrees because all three of the angles add up to 180 degrees. So 180 minus 90 minus 32 equals, if we do this on a calculator, 180 minus 90 minus 32, 58. So then that would be angle A, 58 degrees. So now we're trying to find the two missing sides. This is 58. So we can set up the same type of problem with the trig ratios, but with different missing variable in the equation. So we'll have the angle, and we can solve for a variable in the ratio. So say we're trying to find side A right here. So we could do the tangent of 32, which would be opposite over adjacent to find this. So tangent of 32 degrees equals 12 over, can label this A because that's what we'll call that side. And so from here it's simple algebra. You multiply both sides by A, and then you divide both sides by tangent 32. So then that would end up being 12 divided by tangent 32. And so A would equal 19.2 feet. Because we have feet over here. So now, there is a couple ways that you can find side C. Again, you can use ratio and the substitution of the sides in the ratio to find for the missing variable. Or, since we have two sides, we can use Pythagorean theorem. And so that would look like 12 squared plus 19.2 squared equals c squared, since we are solving for the hypotenuse. So 12 squared in the calculator plus 19.2 squared equals 512.6 equals c squared. Of course, that's squared, so we have to find the square root. Square root of 512.6 equals 22.6 equals c. Feet. So we find out that the distance from the bird flying from the ground to the top of the building is 22.6 feet, and the distance from the bird's starting point to the bottom of the building is 19.2 feet. And that could help you figure out the angle in here. I mean, we used to see a lot of birds when I was in the Coast Guard, so I'm pretty used to this kind of thing. So since we have all the measurements, we have solved the triangle, given one angle and one side, by finding the missing angle and then using ratios of the angles, trig ratios of the angles, and the missing variable to find the missing sides. So that is solving right triangles in two different ways with real-life applications, and I hope you enjoyed it, and I'll see you next time. Thanks for listening.